All right, here we go, guys. We're going to be talking about rate of change. Now, we've already been talking about rate of change, and we've looked at a couple of ways to find it. So now let's look at some examples. All right. We have a table, and it's talking about the time and distance, the distance that the band marches over time, right? Is the rate of change in distance with respect to time constant? So you guys know how to do this. You know that you have to count. From here to here, it's a +1. From here to here, from here to here, it's changing at 1. So this is constant. So now we look over here. From 260 to 520, is this constant? From 520 to 580, is this constant? And from 780 to 1040, is this constant? Well, let's see. What's 520? That's 0, 12, 6. That's 160. Is that right, guys? Yeah? Am I right? You guys gotta tell me. 8, 7, 6. So it's 260. No, it's not 260. Yes, it is 260. All right. I don't have my calculator. All right. So yes, this is constant and this is constant. Okay. So there's one question. What does the rate of change represent? Well, it represents every 260 feet, they march 1 minute. Every 520 feet, they march 2 minutes, right? So every minute, they can march 260 feet. I'll say it the other way. For every 2 minutes, they march 520 feet. Every 3 minutes, 780 feet. So every 4 minutes, 1,040 feet. Is this linear? Is this linear? That is your question. The answer is yes. Let's move. Now we have a table showing cost of nuts. What is the rate of change represent in this context? Okay, first of all, it's talking about ounces. How many ounces are the nuts is your total cost. So the cost depends on how many ounces, right? This is my X, this is my Y, my input, my output. Cost depends on weight of the nuts. So determine whether the data represents a linear relationship. So if it's linear, that means this has to be a constant rate of change, and this has to be a constant rate of change, correct? So if so, find the slope of the line containing the points given in the table. So all we're doing is finding the rate of change. So from 16 to 32, that's a +16. From 32 to 48, +16. +16, okay? Now from $1.25 to $2.50, that's what? $1.25 to 25. $1.25? Is that cool? And then $2.50, $3.50, yep, $1.25. And then, yep, $1.25. Okay? So now, this is constant, so yes, it's linear. What is the rate of change here? Now remember I told you, it's y over x. The change, remember that triangle? Change in y over the change in x. This means change. So the change is $1.25 over 16. So that is your rate of change. Okay, that is also your slope. Okay, we talked about this. So now I want you to tell me, is this A, B, C, or D? I kind of already gave you the answer, right? Kind of gave you the answer. I told you what depends on what. Let's look over here. We have per, and per, right? So you know immediately after that should be my X value. What is my X value over here? Weight. So it's not this. It's not this. Okay? The weight doesn't depend on the cost. The cost depends on the weight. The cost depends on the weight. Okay? So now you have two choices, A and C. A and C. Linear, non-linear. And the answer is A. Alright. Calculate the rate of change for each linear function. And what does it tell you? So let's go over here. Let's do our rate of change. Here, I'm constantly increasing by a +1. Here, here, and here, I'm going down 3, 7 to 4, 4 to 1, 1 to -2. So I do my change in y over my change in x, and that's -3 over 1, which is equal to -3. So that's my rate of change. This is constant, so it tells me it's linear, and it's already told me if you're linear. And it also tells me that y is depending on x. right? For every x that increases, y decreases 3 times. Now, let's look at this one. This one is the points on the graph. So I'm going to make a table. My x values and my y values. Well, these are my x's. Now I'm going to do it in order, least to greatest. -4, 1, and 6. And then I'm going to do my y's. Also least to greatest. 2, 3, and 4. Now I have a table. So now, as I'm going from -4 to 1 and 1 to 6, that's increasing by 5. And as I'm going from 2 to 3 and 3 to 4, that's increasing by 1. So then I do my change in y over my change in x, and that's 1 over 5. That's my rate of change, right? So the relationship that's going on here, for every x, right? For every time I increase 5 in x, I'm going to increase 1 in y. So this is my rate of change. If you notice, it's going to be in a fraction form. This is also going to be my slope. What is the slope of the line? Oh my gosh. Okay, well I have 2 points here, so I can make my table if you want to with my x and my y's. Or I have a graph. Now we can start calculating rise over run. Remember it this way, guys. When you wake up, you're lying in your bed, you wake up, you open your eyes. The first thing you do is you rise or you fall out of bed. You rise or you fall out of bed. And then you run to the bathroom. Well, okay, I run to the bathroom, okay, because I'm older. So slope, remember you have to rise or fall first before you run left or right. Rise or fall and then run left or right. Okay? So I'm going to take this point. In order to do that, you have to have 2 points, and I have 2 points. So now I'm going to see how many units I rise. I'm going up. I'm not going to go down because my function isn't going this way. I'm going to go up. I'm going to go up 1, 2. So I rose positive 2 units. Now I'm going to run 1, 2, 3. I ran positive 3 because this way is positive. Okay? So I rose 2 and I ran 3. That's my slope. 2 over 3. Ta-da! Ah, what is the slope of this line? Again, you can make a table, right? Instead, I'm going to find my 2 points and I'm going to rise. Now I'm going to rise, or you can start here and you can fall. Okay, it's okay. But remember, if you fall this way, you're going negative. You're falling down, that's negative. You're rising up, that's positive. Okay? So let's do it from here to here. So I'm going to fall 1, 2, 3, 4. So I'm going to fall 4, that's a -4. Then I'm going to run to the left, excuse me, to the right, which is positive. I'm going to run 1, 2, 3, 4, 5. So my rise over run, which can also be my fall, is -4 over 5. If you went the other way, if you rose first, 1, 2, 3, 4, right? That's a positive 4, and then you ran 1, 2, 3, 4, 5. To the negative side, it would still be 4 over -5, which is the same. All right, what is the slope of the line? Now you guys do it, and then I'll tell you the answer. We're going to go from here to here. I'm going to rise 1, 2, positive. I'm going to run 1, 2, 3, 4, 5, right? So 2 over 5, because I ran up, positive, and run to the right, positive. What is the slope of the line through 2 points? Now we're going to be using this. You need to write this down, okay? y2 minus y1 over x2 minus x1. When you don't have a graph, or you don't have a table, and you need to find out your rise over run, guys, this is exactly what we've been doing. Think about it. We've been taking points, we've been calculating, right? Calculating, and then we've been putting y over x. So this is the same thing. You see how it has the change in y over the change in x. And we've been trying to figure out the difference between these 2 points. This is the same thing. So now if you look at it, let's put it in a table so you guys can see x and y. X is -1 and 3. Y is -2. Hold on. I gotta put my points in match. I gotta match. -1 matches with 3. Okay, -1 matches with 0, excuse me, and -2. These are 2 points. Okay. So let's use this formula. So I'm going to label this x1, y1, and I'm going to label this one x2, y2. I'm sorry, you can't read it. It's terrible. So I'm going to take y2. y2 is -2 minus y1, which is 0, right? And I'm going to put it over 3x2 minus -1. And look it, be careful here. This is why I put it in parentheses, a negative and a negative. So -2 minus 0 is -2. 3 minus a -1 is 4. And you can reduce this to -1/2. Okay? You can still reduce this to -1/2. Okay, so let's just ignore this table because this is why we're using y2 minus y1, because they were not in correct order. So remember, y2 minus y1 over x2 minus x1. So let's go to the next one. All right, I'm going to do this one with you because there's 2 points. So I have -4, 3, and I have 5, -9. I'm going to put x1, x2, y1, y2. Let's color coordinate it. There, that looks a lot better. And we're going to use y2 minus y1 over x2 minus x1. Okay? So now let's see what we get. So let's use y2. y2 is -9. I'm going to use the minus sign. Minus y1 is 3. Over x2 is 5 minus, because that's right here. x1 is a -4. Remember, don't just write 4. You have to write the negative and the -4. So now, -9 minus 3 is -11 over 5 minus a -4 becomes positive, and that's 9, right? So now let's look over. Oh, what did we do? What happened? I'm going to let you figure it out. Ha, 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 ha. And you get to mix it. Okay? I want you to write what happened, what I did wrong, and then I want you to circle the right answer.